Well, this is the last video of our test review, and this one says that 11 cancer patients have been approved as candidates for an experimental treatment. 6 are adult men, 3 are adult women, 2 are adolescents. Because the hospital can treat only one patient, a person will be selected at random. Find the probability of selecting an adult. So we have 6 adult men. I want to summarize it here real quickly. 3 adult women. And then we have 2 adolescents. All right, so what is that total up to? 6 and 3 is 9. Oh, we already knew that there were 11, but we needed to break them up like this into the categories. So, find the probability of selecting an adult. Well, we're only choosing one person. So how many ways are there to choose one person out of 11? 11. So that's the denominator. Now we need to see how many individuals are adults. And that's this group right here, 6 and 3, 9. So that's the answer. 9 over 11. 17. A jeweler's bag contains 6 rings. 1 is plain gold, 1 is plain silver, 1 is gold with emeralds, and 1 is gold with emeralds and rubies. 1 is silver with diamonds, 1 is gold with diamonds and emeralds, and 1 is silver with rubies. Whew. All right. If a ring is selected at random, find the probability that it does not have rubies. All right, I don't want to write all this down again. So there are 6 rings, and we want the probability that the one ring selected does not have rubies. So 6 is the denominator because one ring out of the 6 is being selected, and now we simply need to count up the number that do not have rubies. All right, this one does not. So I'm going to count up the ones that don't have rubies. 1, 2. The next one has them, so don't count it. 3, 4. This one has it, so don't count it. 4 of the 6, 2 of the 6 have rubies. 4 of the 6 do not, and we want to know the probability that it does not have rubies. So you could leave the answer like 4/6, or if you want to reduce it, you could put 2/3. Number 18, a wallet contains 7 $1 bills, 3 $5 bills, and 5 $10 bills. A bill is selected at random from the wallet. Find the probability that it's a $5 bill, given that it is not a $1 bill. So we could plug it into the formula, but this one is really quite simple. The probability that it is not a $1 bill. Okay, I'm sorry, given that it is not a $1 bill means we're selecting from this group right here. Because this is false, it is not a $1 bill. So we know it's not one of the 7 $1 bills. Since we're selecting only one, what is the probability that it is not a $1 bill? Ooh, actually, let me say that again. Find the probability that the bill is a $5 bill, given that it's not a 1. So given that it's not a 1 means this is really becoming our whole sample space. If we choose 1 out of here, what's the probability that it is a $5 bill? How many $5 bills are there? 3. Out of how many total? 3 and 5 make 8. So very simple. That's the probability. Number 19. Last problem. A card is drawn from a well-shuffled standard deck of 52 playing cards. Find the probability that the card is a king, given that it's a face card. Well, that's pretty simple. Remember that the face cards, sometimes called picture cards, same thing. They are the jacks, queens, and kings. All right, so given that the card is a face card, this is what we're dealing with. There are 4 of each. So we're dealing with a total of 12 cards, and one card is being selected. Given that it's a face card, we're choosing one out of this. The probability that it is a king is going to be, well, there are 4 kings out of 12 cards. The denominator is not 52 because of this statement right here, given that it is a face card. So you could leave it like 4/12. If you want to reduce it, you can, but that would be 1/3. But 4/12 is perfectly good.